In this video, we're going to continue our discussion on air conditioning diagnostic. And again, these are procedural videos. Your real life may be a little bit different than this, but this series is designed just to give you an idea of the proper procedure to fully test a piece of equipment. So we're at our condenser diagnostic, and for whatever reason we need to do it, we need to test the compressor. Okay, let's start easily. Do we have voltage at L1 and L2 of the load side of the contactor? In other words, is the contactor closed and do we have voltage? Okay, if we did not have voltage when we measure it, we need to go back and look and say, is the circuit breaker tripped? Okay, if the circuit breaker is not tripped, we need to resolve the power issue before proceeding. Okay, we've already done our condenser diagnostic previously, so we should have power at this point. My condenser fan should be running. So you missed something. If the circuit breaker is tripped, okay, let's disconnect the power and remove the compressor wiring harness. Okay, in other words, we already tested the condenser. We know we have power there. Okay, now we've come to test the compressor, and all of a sudden we have a tripped circuit breaker. Let's disconnect the power for safety and remove the compressor wiring harness. The first thing you're going to do is change your meter to ohms, okay, to resistance. And you're going to check the resistance between R and C, resistance between S and C, and R and S. Now, is there resistance? Okay, if you have a 0, it means it's shorted. If you have infinity, it means it's open. Okay, most of your digital meters will show OL. Okay, so if you have either a 0 or an OL, it means our resistance, the winding has failed. You don't have any choice here. It's to replace the compressor. Now, if you have proper resistances, okay, and by the way, R to S will be very close to the sum of the two numbers you got from R and C and S and C. Okay, R to S checks the full circuit. Okay, if we have proper resistance, the next thing we're going to do is check and make sure that we don't have any shorts to ground. You're going to take one lead, you're going to put it on the terminal, the wiring terminal of the compressor, and you're going to take the other lead and have it securely touching one of the copper pipes coming out of the compressor. Okay, so you're going to do a short to ground check. Okay, if you have anything below a 1 meg short to ground, in other words 512K, 6, whatever, you need to, that compressor is shorted to ground. Okay, and the compressor is going to need to be replaced. There's no way around it. Now, before you replace the compressor and before you go through that whole procedure, okay, of refrigerant recovery and everything, you want to do an acid check. Is there acid in the compressor oil? Okay, very little. There's quick acid check test kits you can get that are very inexpensive and very fast. Okay, has a piece of paper in it that turns color if the refrigerant oil has acid in it. So if the acid does not have oil, go ahead through the compressor replace procedures. If the refrigerant oil does have acid, you still have to replace the compressor because the compressor is bad. But you need to install a cleanup filter dryer and flush the system. Okay? You got to get rid of that acid because acid will just burn out the new compressor. So, we've now come down, we've tested our windings, we've checked for acid if we have a shorted to ground winding. You're going to remove the leads from the HERM terminal on the capacitor. I suggest removing the leads from all the terminals on the capacitor, and you're going to test the capacitor. Okay, is the capacitor good? If it isn't, it's usually like between 5 and 10%. Look at the label, okay? And if it's outside of the variance, replace the capacitor. Okay, if the capacitor is good, reconnect all wiring and energize the system. Now, just one note, if you end up replacing the compressor, okay, which is up here, you will always replace the capacitor. Do not ever replace a motor And a compressor has a motor in it. Do not ever replace a motor without replacing the capacitors. Okay, reconnect all wiring, re-energize the system. Does the breaker blow when starting? Okay, if it does blow again when you start the system, verify all connections and make sure that no wiring is grounded. Look for things like, okay, maybe an animal, especially like chipmunks and mice, like eating the insulation off the wires. Look for things like little rodents that have gotten into the up in behind the wiring connections on the contactor and may be tripping it. Okay, now if you are still tripping the breaker, okay, when that compressor starts, and if everything looks good on wiring, you don't have any shorts to ground, again, check amperages, okay? Check everything else that could be pulling that compressor up, okay? If the compressor amperages are high, okay, you could very well have an internal component bad on that compressor, and there's only one choice. You can't fix it. It's to replace the compressor. If the breaker does not trip, verify the system has refrigerants. Okay, verify that the pressures change when the compressor's running. And this is the point where we're going to return to the condenser diagnostics, because we're going to look much closer at the refrigerant pressures. But the compressor's real easy. If you have voltage, if your windings are good, if you don't have acid in the system, and if your amperages are good, okay, your compressor's most likely good. There's one more case where the valves might be bad, but we'll pick that up when we look at the refrigerant.